In this video, we're going to talk about die casting. And die casting is a high volume production manufacturing process. This means it is not a good choice for making one-off parts. If you're making, a small handful of parts, you do not want to do die casting because very similar to injection molding, you have to invest in very expensive steel tooling before you can make your first die cast part. And that tooling is very costly, tens of thousands of dollars. So once you have the tool, your part cost, however, is very low. You might pay a few dollars for a part or something like that, maybe even less. But it's a very low cost, and the parts are produced very quickly in a matter of minutes. So it's a high volume process that is low cost once you have the tool. But if you're making 100,000 parts and your tool costs $50,000, then I think that works out to about 50 cents per part. In your tooling cost gets amortized out to about 50 cents. And then maybe your part cost is another $1, so it's $1.50 total for this part, and you're pumping them out, every couple of minutes, so very quickly. So
you said the word amortized. Could you tell us what that means in this context?
Sure. Yeah, amortized is more of a financial term than an engineering term, but it is used in the context of paying for the tool, for an injection mold tool or a die casting tool, or any tool that's expensive but is going to be used across a large number of parts. So if we only made one part and we created this expensive tool to make that one part, let's say the tool is $10,000 and our part cost, the material involved and the time involved in producing that one single part was $1. So you're paying $10,001 total for one part, which clearly doesn't make any sense. So your amortization is not beneficial in that case. Of course, if you're making 100,000, well, let's make the math easy. If you're making 10,000 parts, then the $10,000 cost of that tool gets amortized into each of those $10,000 parts. And now all of a sudden you're only paying $1 for your tooling plus the $1 part cost, so it's $2 per part. And in that case, the amortization works out much better. And you can imagine the higher quantity you go, the better the math becomes. Now, at a certain point you have to stop because your tool will not last indefinitely. Your tool might last for hundreds of thousands of parts, or maybe even millions of parts, depending on the quality of the tool and the part geometries, but it won't last forever. At some point it will need to be either reworked or replaced altogether.
If we were going to be making a very high number, thousands, maybe even millions of metal parts, would you say die casting is the best method, the best process that we have?
Yeah, that's probably the case. And that's a good point. Die casting is a process used with metal parts, only metal parts. Aluminum, zinc, those are very common materials to use in die cast parts. Magnesium and brass, those are also common. I think more often than not you see aluminum or zinc parts, but they're metal. They're soft metals, but they're metals, and so the parts produced by die casting are really pretty strong. And that's one distinction of die casting versus injection molding, is that if you're injection molding parts, if you're plastic injection molding parts, then you're getting plastic parts which aren't terribly strong from a structural standpoint. Whereas die casting, you're getting metal parts, so these are very strong parts, and that's a key differentiator of die casting. If you found this content helpful, consider enrolling in our signature program at mypipelineacademy.com. Whether you're an individual interested in beginning a new career as a mechanical designer or a company interested in training your new engineering hires, our signature program helps students develop the practical skills they need to be productive mechanical design engineers. Seating is limited. We hope to see you there soon.